Determine the domain, range, and asymptotes of f of x equals 3 over x. Now this is a reciprocal of a power function. Now the power function would just be f of x equals x, which is a straight line that goes through the origins and quadrants 1 and quadrants 3. Now when you take the reciprocal, that means you just flip it. So in this case, it was originally 1/3 x, and then when you flip it, it becomes 3 over x. That 1/3 is what determines if it's stretched or compressed. So the original power function is f of x equals x, but now we have a reciprocal of the power function. How are we going to determine the domain, range, and the asymptotes of this reciprocal power function? Chloe is here with her latest cheat sheet notes. She wants you to know that the domain is the x values and the range is the y values. The vertical asymptote is the vertical line that the function gets close to but never touches or crosses, and the horizontal asymptote is a horizontal line that the function gets close to but never touches or crosses. Now that we have Chloe's cheat sheet notes, let's go ahead and look at the graph of f of x equals 3 over x. You can see that part of my function is in quadrant 1 and part is in quadrant 3. Now if you were to actually zoom out on this graph, you would see that the function gets very close to both the x-axis and the y-axis in both quadrants, but it will never cross and it will never touch either of those. So the first thing we're going to do is find the domain. Now when we're looking for the domain, it's the x values, and our x values are the horizontal axis. So as I go left on my horizontal axis, where is my function getting closer and closer to? What x value? It is getting closer to the x value of negative infinity. So since negative infinity can never have a closed bracket on there, you have to have the open unbounded parenthesis. Then as I go to the right on my x-axis, my function gets closer and closer to what x value? It gets closer and closer and closer to where x equals 0. It'll never cross it. So there is negative infinity, 0. But we're not just finished with our domain, because if you look on this side of the axis, you will see that as you go to the left, your function gets closer and closer and closer to the x value 0. So we also have another part of our domain. And as we go to infinity on our x-axis, our function also goes to infinity as an x value. So our domain is negative infinity, 0, and 0, infinity. The next part we have to find is the range. Now, the range is the y values. The y values are up and down. So the y-axis is up and down. So we're going to do the same thing here. As we go down on the y-axis, my function gets closer and closer and closer to what y value? It gets closer and closer to negative infinity. Then as I go up the y-axis, this function in the quadrant 3 gets closer and closer and closer to what y value? It's closer and closer to the y value of 0. It'll never cross the y equals 0 line. It'll never touch it. It just gets closer to it. But then if you look in quadrant 1, we also have a part of our function in there. So as we go down on the y-axis in quadrant number 1, our function gets closer and closer and closer to the y value, y equals 0. So we know that we have 0 as our first part. And as we go up the y-axis here, our function gets closer and closer and closer to what y value? It gets closer and closer to the positive infinity. So our range is negative infinity to 0 and 0 to infinity. Now we have to figure out our asymptotes. We're going to do our vertical and our horizontal asymptote. Now, a vertical asymptote is the up and down asymptote that your function gets close to but never crosses or touches. And the horizontal is the line that it goes left and right, and it's the same thing. Your function gets closer and closer to that horizontal line but never touches it, never crosses it. So if we were to look at our graph, we can see that I actually could draw a horizontal asymptote here at our line x equals 0. Both of these right here, as you can see, this function in quadrant 1 would get close to it, never cross it or touch it, and in quadrant 3 gets close but never touches it. So our horizontal asymptote would be at y equals and that's right here is at y equals 0. Then for our our vertical axis, it goes up and down. Our vertical axis, you can see right here, is our x equals 0 line. And why is that? Because you can see in quadrant 1 and quadrant 3, both parts of the function get very close to this x equals 0 line, but they will never cross it. So our vertical asymptote is x equals 0. So these are our 4 answers for this problem.